Network infrastructures support our daily lives. High-speed communication networks play an important role in a variety of fields. Corporation and public service infrastructures, to say nothing of internet access, optical phones, and video on demand in the home. Fiber optic communication has been evolving steadily by incorporating new technologies to further increase the communication speed and capacity of the backbone network, which is the nucleus of these communication networks. NTT Network Innovation Laboratories have carried out a successful experiment which achieved the transmission of 102 terabits per second of data, the world's highest capacity, over a distance of 240 kilometers, using a number of 400 gigabit per second channels, which made use of the latest digital coherent transmission technology. It has become possible to send data at 102 terabits per second over a single fiber, largely owing to the use of the newly developed multi-level modulation technique employing a digital analog converter, or DAC. Unlike conventional technologies, which have achieved multiplexing using phase and polarization information, our new technology combines phase information with amplitude information. Specifically, we combine one of 8 possible magnitudes of cosine curve with one of 8 magnitudes of sinusoidal curve to yield 64 values. This makes it possible to send 6 bits of data per symbol. Furthermore, by using 2 orthogonally polarized waves with this technology, it is possible to send twice as much information, namely 12 bits of data per symbol. What kind of new technology has been applied to optical amplifier repeaters? In conventional communication systems, signals that are attenuated as they travel through an optical fiber are amplified using an optical amplifier called an EDFA. However, the EDFA amplifies both attenuated signals and noise that is mixed with them. Therefore, it is not possible to send clean signals over a long distance. So, instead of an EDFA, we have applied a new technology called distributed Raman amplification. This technology uses optical fibers themselves as the amplifying media. By applying, in the opposite direction, pump light from sources at wavelengths different from those of the data signals, the data signals can be amplified within the optical fiber itself. This has made it possible to achieve long-distance transmission while the noise level is kept low. We have conducted a successful experiment of transmission over 240 kilometers by amplifying the signals 3 times at intervals of 80 kilometers. By applying 64-level modulation to 152 gigabit per second signals, we have achieved 457 gigabits per second transmission per wavelength, which is 3 times as high as the original capacity. With this ultra-high-speed transmission, it is possible to accommodate a 400 gigabit per second Ethernet. When 224 wavelengths are used, the total transmission capacity becomes 102 terabits per second, which is the world record in transmission capacity on a single core fiber. There are high hopes that optical communication will continue to advance in both transmission capacity and distance. NTT Network Innovation Laboratories are aiming to make further technical strides in this field.